Hi everyone. In the given problem statement of combination sum, we are given an array of distinct integers, candidate and a target sum. Return the list of all unique combinations. So this is a very important thing. All unique combination of candidate where the chosen number is equal to the target. So here, right, if I follow this pattern, let's say 2, 3, 6, 7, and let's say if I have an option of adding 2, and I can add 3, 6, 7. Then again from here I can add 2, 2, then 2, 3, 3, 2, 3, 3, 6, 2, 6, 3, then 7, 2. Whenever we reach 7, right? So 7 is the target, so it would be passing up. So we got one value out here. But here, right, if you're able to see, right, then 2, 2, 2, 2, 2, 3, 2, 3, 2. So these two are same, right? And both of them would be resulting to 7, right? But the problem is arising because both of them are not unique combination, right? You have to find only the unique combination. So how to do that? So one way of doing it, right, we can take a value and skip the other value. How am I saying it? Let us take this example, our candidates, and I'm going to take a small one so that I can draw the decision tree. So candidates, what are the value is 2, 3 and 6, and the target is 6. So initially write 0, our empty list. What does it mean? Let me explain, right? So 0 is basically the current index I am at. This is the subarray that we are forming, and this is our current sum. Okay. So it will be starting with this index which is at 0th position. So from here, right, I have two options. One, I can basically add 2. So my current index would become 1. My sub array would become 2. And my current sum is also becoming 2. Where I chose to add it. So, and the other one, I can skip. So skip is basically means, right, I am not adding any value to here. So our current index, I'm just skipping it, means I'm going to the index 1. Our subarray is becoming empty and our sum is also remaining 0. Now from here, right, I again have two options. I can add 1. So I can choose 1. So in that case, right, and here, right, just I made an error. So whenever you're choosing the first option, right, we are not going to increment our index. Our index is going to remain the same. So in this case, right, our index remain the same. Our combination, right, is going to have two 2's, and our current sum value is going to 4. If I skip it out here, then what the value would become? It will become 1. It will be 2 and 2. So from here, right, I can again choose index 1. So we are choosing that value. So index 1 is 3. This is skip. So 3, our current index would be 3, and our current sum, this index is going to get incremented by 1, and our current sum is 3. Other option is that we can again skip. So again skip basically would mean, right, our value would become, this will be 1, sorry. Whenever you're adding it, right, we are not going to increment the index. So, and when you're skipping it, we're going to increment the index. So our value is going to be empty and this is going to be 0. Again, we are going to add the elements. It would be 0. We are going to add this. So it would be 2, 2, 2, and the value would be 6. So which is a correct value, and we are not going to do anything because we got our result. In the other option, we are going to again skip it. So it would be 0, it would be 1, 2, 2, and 4. From here, there could be two possibilities. One would be adding it up. So now the value of this one is going to be 1. 2, 2, and 4. Other would be to skip it. So now current value would become 2 with an one value, and the sum is 2. In this case also, what I can do, I can have two options of adding the value at 3, which would going to make our value would be 1, and here it would be at index 3, right? So 3 and 3, and the value would become 6. So we are going to add it, and the other option is going to 2 index to skip it, and the other one would be remaining 3, and this value will remain 3. And from here there are two options. So one would be to add this value, so we would be at 2. So adding 2, it basically means 6, and our target sum is also going to be 6. So this is the correct one. The other option is to skip it, but if I skip it, right, we are going to exceed the current list of candidates, right? So in that case, we can also cross it because it's no longer possible. So as of now, right, if I look into it, right, I found a few possibilities out here, but there could be more. And how to do it? Let us check it out. So out here, right, I can add a value which would make it 2. Sorry, it would be 1, and the other one would be 2, 2, 3, and the value would be 7. It exceeded, right? So you can cross it out. The other option is going to 2, and when skipping it, 2, 2, and 4. From here also we can, one option could be adding it. So if we add it, right, it's not going to, I think it would be 0, but anyway, if we add it, right, it will be more. So if we look into it, right, all of the other option, and you can draw the decision tree, right, it's going to take some time, but the basic idea is, right, the only 3 options that is available for us, right, all the valid combinations are 2, 2, 2, 3, 3, and 6. So these are all the valid combinations. Here I am not, because here this is only one way of doing it, right? Means if I had to draw the entire decision tree, it is going to be a big one, but you get the gist, right? So you can have two things, right? One, you can take the current index, add that value to your subarray and to your current sum. Another option is to skip that value, increment the current index by 1. So that's the basic idea. Now let us jump to the Python solution. So if we do that, I think things are going to get even more clearer. Let's jump there. So the first thing that we need to do, right, we need to get the result, which is going to be an empty list. And also we need to calculate what is the length of our array. So I can say length of candidates. Now I can define my backtracking function. So backtracking. Here I can pass in few values. One would be the index. At the current index I am, the subarray, and my current sum. So here the first thing that I'm going to check, right? If my current sum equal to target, so that basically means that we have reached our current sum. What we can do, right? We can do result dot append, and I can say add our subarray to this value. But simply adding it, right, wouldn't be working because it's a recursion, right? So the elements in our subarray, right, would can change. So pass by reference won't work. So you have to pass it by value. So one way of doing it, right, you can just use a copy function to copy the entire element. So a new instance is getting added to the result and not a reference. The other thing is, right, if my index becomes greater than equal to n, or my current sum is greater than the target, in that case, right, we have gone beyond, so we can terminate the current recursion. And here also I have to type in return because I want to terminate it up. So those are the two options. Then I can say subarray dot append. I want to append the current value, so it would be candidates of index to our current subarray, and I can call the backtracking function, and I can pass in. So whenever, right, we are adding it, right, our index is going to remain the same as we discussed, and our subarray, we have already added the value, and our current sum, we have to increment it by the one that we are adding. So dates of index. In the other case, what is going to happen, right, we can skip it. So I have to say subarray dot pop backtracking, and here I would be incrementing the index by 1 and the subarray and the current sum. At last I have to call this one, so backtracking, the initial index would be 0, empty subarray and 0 current sum, and at last I can return the result. I hope this should work unless there are some spelling errors. Let me run it up. As you could see, it is running properly, and let me submit it. As you could see, it ran successfully, but the problem with this one, right, is that the time complexity of it, right, is going to be 2 to the power, like, total number of combinations that are possible. So it can be in very, very high number of possibilities. So it will to the power n, in that range, the time complexity is going to come. So this is a backtracking problem. So you have to go through it and understand where and why we are making a backtracking, so to make sure the solution works. That's all for this video. See you in the next one.